My dad had a stroke, and I was very concerned about the whole medical process. The problem is when you're going into an ER, there's a wait period to get in. For stroke patients, time is brain. The faster you can get to the hospital, faster you can get that imaging taken, and the faster you can get that analysis, it's potentially saving that person's life. So when the opportunity came up to participate in CRIS, I jumped at it. I really understood the impact it could have on people's lives. My name is Maureen Duffy, and I am a principal interaction designer with Red Hat. So as someone who's very focused on user interfaces, the way I would describe CRIS to end users, think about if you ever used like a photo processing program. So you have an input of an image, it could be a medical image or it could be a picture of a cat. And you take that picture and you can apply a series of transformations on it. I could take the cat, and then I could add a mask to it to cut the cat out, and then I could put some background scene behind the cat, and then I could add sort of a pink color cast to the whole thing, and then run some other filter and have this pink flying cat. CRIS allows you to do that with different image processing tools that are specialized for the use case, and you can save those settings, reproduce them, share them so that other researchers can benefit from your playing around and figuring out different ways of getting data out of that image. One of the things that's great about working in open source as a designer and working on a project like CRIS particularly is I'm not focused on using psychological tricks to get people's eyes on the screen and looking at advertisements and clicking on things. It's where our collective effort should be in helping people and helping them stay healthy.
Welcome, everyone. We're so excited to have you. Welcome to the Day of Learning Red Hat Impact Hackathon. You made it here, so we're glad you're joining us, and you have already hopefully completed the steps to get onboarded, but if you haven't, we'll tell you also on this call. So before we go any further, let's do quick introductions. Chris.
I am Christopher Tate, and I work with the research engineering team here at Red Hat to work on projects related to social innovation. And I'm from Salt Lake City, Utah. That's me.
Mo.
Hi, I'm Maureen Duffy. I'm a UX designer. I work in the foundation engineering department and in the artist formerly known as PNT. And I'm based out of Boston, Massachusetts.
Awesome. Thank you, Mo. And you already saw her because she's famous because of the video. So I'm Alexandra Machado. I lead our social innovation program at Red Hat. And also I lead a Red Hat Impact program that we'll tell you a little bit more about as we move forward with this kickoff call. But we just saw the video that is so inspiring. We sent also the whole series of creating CRIS to your inbox. If you haven't had the chance, watch it all. It's amazing. But related to that video, we want to hear a little bit more about you, like from you directly, Mo. So tell us more about your involvement with the CRIS project.
Sure. So you kind of know from the video how I got started, my interest in the project, and being based out of Boston, kind of in the same region as the Boston Children's team and the Mass Open Cloud team that we've been partnering with on the CRIS project has been, helpful too in getting started. I think I would describe myself as one of the lead UX person. So for any of CRIS's user interfaces, including the core CRIS UI and the CRIS Store UI, and just thinking through user experience issues with CRIS, I'm kind of a good person to talk to. And just in terms of CRIS as a project to work on, it's very fulfilling to work on, just because any progress that we make as a project is open. It's not, we're not looking to make anything proprietary or secret, or there's no profit motive. It truly is to like use the best of open source software to improve patient care in an open, accessible way. And the way that the whole system is architected on sort of hybrid cloud principles that are so important to Red Hat also sort of connects the technology, like not just the open source principles, but, Red Hat's strategy and, hybrid cloud being a good way of building technology. I think it connects on so many levels with everything we do, and just on a human level of improving people's lives for the better. So it's just a fantastic project to be involved with.
Awesome. Thank you, Mo. That's amazing. And I know at a personal level, it was really important to you to be connected to the CRIS project. And even right with your department and, the PNT and the research team, it has been a partnership of years. Can you expand a little bit? Like, it's not just a thing that we're doing now. I mean, it keeps growing, but how long have we been involved? How did it start? Could you share a little bit more with us about that?
Yeah, I'd say at least it's the start of the pandemic, right? Because we kind of got together. There was an open source project called COVIDNet that had come up with an X-ray machine learning analysis of chest X-rays. And this is before we had COVID tests available in hospitals, and hospitals were getting flooded with patients and trying to triage between a COVID patient and someone who was not a COVID patient to keep them separate was really difficult because they had no way to test. So this group had come up with this machine learning language. And I think we all kind of had a conversation, because I think that the group that put this open source tool together, I think we had a connection with them, and they were kind of looking for a way, they had no user interface for it, no way to deploy it. And CRIS ended up being a really good way to deploy that tool. We actually tested it out at various hospitals in Canada that were looking at trialing it. And of course, as the pandemic wore on, tests became more available, and, it didn't end up ultimately being a tool of diagnostic use in the hospitals, but it was really fulfilling to kind of have us come together as a team and make the connections between different open source projects and actually build something that could be put in front of doctors to test. And that's the sort of thing that CRIS as a platform can enable. Like, CRIS isn't specifically focused on, say, solving COVID related issues, but as a platform where open source code that can help can be deployed, it makes that possible to have that quick turnaround.
That's awesome. Thank you, Mo. And that's the type of work that, under our CTO's office and also PNT, some engineers are involved and not all of Red Hat knows. And then there are open source projects, so anyone could contribute to them. And that's why we're also making this connection a little bit like deeper, and providing this opportunity to do like hack away together on this project that Red Hat has been supporting for years now, like Mo mentioned, and even a little bit before the pandemic, because also that relationship with like Mass Cloud, that we have that connection, and also with Boston Children's Hospital and the work that they do. So that's really inspiring, and we're very happy that we could provide this opportunity on the Day of Learning together in partnership with Red Hat Impact, which, Chris, I love your shirt. So tell us,
Thanks.
and he has been involved with the CRIS project too, actually last year. And could you tell us more about your connection also to the CRIS project and how you have contributed to it?
Yeah, that was back when I was a senior consultant doing consulting work, and it was during the pandemic, like Mo was saying, and I was a bit discouraged that we weren't getting together and working on things together at Red Hat. So Alexandra reached out to me because we've worked together on social innovation projects, and she said, we want to put together this hackathon, and part of that will be in North America, and it's with the CRIS project. And I said, yes, let's do a hackathon. I got to dive in real deep, and Mo reached out to me to share her list of ideas that she'd been putting together on the containers that are important to the CRIS project. And meanwhile, I was working on figuring out how to deploy that CRIS project on my RHEL 7 machine and also on the RHEL 8 machine, because RHEL 8 was very new. So just moving medical imaging forward by discovering new containers that can be built and figuring out how to deploy these on various operating systems, because that's what we need as doctors in faraway places and everywhere to be running these containers and finding solutions in their files, in their images, in their videos that can advance medical imaging and help the lives of people out there in the world. So we got together again for this engineering day of learning to do another hackathon to drive forward more of those containers that can be built to enhance medical imaging. So I'm grateful to both Mo and Alexandra for working with me as a team to bring this hackathon to life with the CRIS project.
Awesome. Thank you, Chris. And I think it's making those connections, also passionate Red Hatters that are doing this type of work and sharing it with you all. And going into Red Hat Impact, so we have partnered with the Day of Learning team that has provided the amazing opportunity to do this hackathon for all of you. And what we do at Red Hat Impact is actually leverage our skills, and we like to call it our superpowers, Red Hat superpowers, to help open source projects that are doing impactful work in the world. And that's one of the projects that we support on an ongoing basis is the CRIS project. So what Red Hat Impact we launched earlier this year, you're going to hear more as we start to build more like events and hackathons in the future. But as of now, I mean, we launched this year, and it's our skills-based volunteering program. So it's actually making that connection, like giving back through our skills to impactful open source projects. So it has that aspect of soft skills and technical skills related to our work, but translating them into, socially, environmentally impactful projects. And so that's what we do. If you want to check out our ongoing projects or more of what we're doing across other departments and regions, just check us out on the source page. You can look us up actually in the menu at the top, and it's there right next to Red Hat Cares. And you can click and you can uncover a little bit more of what the work that we're doing. Well, with that said, I mean, so now talking about the hackathon, we just wanted to give you this brief kickoff introduction, hopefully inspire you to win. So as you know, we have big prizes, and it's also going to be team-based. So we hope you enjoy that setting of teams that also winning. So at this point, you should have your team. If you don't, please check out and I'm going to refer you back to the onboarding email that we sent to you either on last Friday, or this Monday. So check your inbox. If you need to get in touch with us and to ask questions, please join the Day of Learning chat on Google Chat. It's also in the email. So you can click there, join the chat, and ask any questions that you have throughout the day. We'll be there just waiting for your questions. And then that onboarding video, the email has a video that you need to watch. So if you haven't watched it, please go back and watch that onboarding video that has all the technical details that you need to be onboarded. And then again, if questions arise, you can ping us in the chat or by email too. And you have all that information in the email, in the communication that we have sent so far. So without further ado, I mean, the next part of this video will actually be Rudolf Pinar introducing you to the CRIS project. So Rudolf is the technical director of Fetal Neonatal Neuroimaging Developmental Science Center at the Boston Children's Hospital. But in simpler words, he's the technical architect for the CRIS project. So he works at the Boston Children's Hospital. He's our champion, to put it in that way. He's a genius of sorts, and we're so happy to have him lead the way with this project and have and be connected to him. So he will give you firsthand the explanation of the CRIS project and the vision too that you're part of now, because you're going to help us through this hackathon get there. So without further ado, I mean, we hope you enjoy Hacking Away, and we hope you enjoy the experience and you enjoy the contributions that you make. And we'll pass it over to Rudolph. Thank you.
So we're a small team over at Boston Children's. So my background is technical. It's electronic engineering and biomedical engineering. So I need a small team that we've put this system together, and now with a lot of collaboration and help from other folks, especially people at Red Hat, it's definitely growing into the next generation of stuff. So without, I could talk about how important open source is, right? I think I'm kind of preaching to the choir here. I will say that a lot of people think science is kind of like open source, to which I will say, yeah, kind of no, it's not. Science isn't like open source. There's an openness in science, but there are a lot of barriers that typically occur in science, artificial ones, in my opinion. People are very zealous about their data, about sharing, getting publications out, yada, yada, yada. So our approach is to bring open source fully into the scientific kind of mindset. And computational science is one of the things that is, I think, on the forefront of inspiring this. So we're also trying to show what we can do with open source kind of tools to make an impact in a clinical environment, but also in research as well. But this is a huge topic that I can't even fully get into. I will say that everyone will probably agree, right? We're living in a time, what is it, 2021, where there's this huge rush. The currency of the time in computers is data. Everyone wants to get data. Everyone wants to do AI. I have a lot of thoughts about quote unquote AI, but the thing is, do we want to help create a world in which data is owned and compute is owned by huge corporate interests? I think it's fundamentally important to have kind of compute and data in platforms that are pervasively open source. I think it's fundamentally important, right? So this is also part of the inspiration and stuff that we're trying to do in this project as well. But okay, so I'm going to tell a story, and I'm going to kind of jump kind of into it without explaining really what CRIS is and what its architecture is. We can get to all of that, but I'm going to try and tell the little story over here. So here I'm logging into an instance of CRIS here on my local computer at home. And let's imagine that that I'm originally from South Africa, so we don't have to imagine that. But let's imagine I'm a doctor somewhere out in the rural, some province of South Africa, where I might have connectivity through a cell phone network, and probably I might have a computer. I mean, I definitely would probably have a computer like a laptop or computers at the hospital, perhaps. But maybe healthcare is very thin on the ground. So let's imagine I'm one of these doctors out in some rural province, and I have CRIS installed on my local laptop, which is very possible to do. And that's what we kind of want people to also think of this system. It's not a system where it lives in Boston Children's Hospital or one or two places in the world. We kind of want a whole network of CRIS instances all over the place. So let's say I log in, and this is all public data that I'm allowed to show and stuff like this. I'm going to simulate me speaking to the hospital database and asking it, show me the images of this particular patient, right? So now, and this is all live, I'm kind of doing this as I'm going along. And it comes back with this is all anonymous, and I click down, drill down, and I finally get to the actual image. And let's take a quick preview. So here's a lung CT, and let's imagine that for whatever reason, I'm not really sure what this image is representing. It could be a difficult read, it could be a complex case, it could very well be that I just don't have the experience to do this. Now, normally what would happen, I suppose, is any number of infinite things. You could have a misdiagnosis. You could rush through this. You could basically just essentially move to the next one or something like that. But what if you could collaborate in a larger community? What if what you could do is you could post this image in a secure fashion to a distributed network and ask for help. You could say, hey, does anyone have any ideas of what this might be? Some kind of larger consultation process. So let's imagine I'm doing that. Now, the current version of Chris doesn't yet have different Chris versions speaking to each other, but that's definitely in the next version. The backend that we have is able to do all of this kind of stuff, right? The REST API is powerful enough that from a client side, you can essentially speak to a Chris instance and share all of this kind of information. So let's say we do that. Now, imagine, if you will, on the left over here on my dashboard, imagine I had a panel which I don't currently have, which could be sharing or network or social. And let's imagine in that panel, what happens is that a collaborator, and let's imagine this is somewhere in, let's say, Brazil, right? Let's do the Southern Hemisphere, sees my post and is able to look at this. And I'm trying to show the two different browsers here. This is Firefox with a dark background, whereas my one over here is with a light background. So this is the Brazilian team looking at this image. And let's imagine they're researchers or whatever, and they say, you know what? We have a compute. We have some kind of analysis that we think could give you meaningful information on this data, right? And I'm in South Africa, I'm saying, oh, cool, this is amazing. What do I need to do? Well, they say, just go to the Chris store and install our app, right? So I'm like, cool, that's amazing. So let me go to the Chris store, which is up and running over here. Actually, let me go to the main page. And you can sort of follow along if you wanted to click on all of these things. But for the sake of the story, I go to the Chris store and they told me that they have an analysis stream called infant analysis. Let's just say. So I type that in and I get a hit. And here is the store front end showing me this compute. Now, it needs a lot of work. I mean, it's kind of rough around the edges, but the idea, of course, is that we're pulling the kind of README from the GitHub repo for this compute, et cetera, et cetera, et cetera. But the critical thing is, for me, I want to now just run this on my Chris out in wherever I am. So I just hit this button, install to Chris. I jumped one or two hoops, which we want to get into. This obviously can be all streamlined. And let's say I've done all of that. So now I'm back over here. So now I'm super excited. I've installed this workflow to my analysis. So now what I can do is I can go, let's just simulate this again. I can pull that data set, drill down, look at this image over here, and now I'm going to create a feed. By feed, I mean an analysis. We're busy changing some of the names of stuff over here to make it less confusing. But anyway, we call this a feed. So I'm going to hit create feed on this, and I'm going to call this COVID analysis. And I'm going to click through here, and I'm going to choose the COVIDNet pipeline that I've just installed onto my system. And imagine in the back of your mind throughout all of this that the typical user in this case is a physician, and physicians as a whole are very computer illiterate. They're going to do the least amount of work that is possible for them to do. They're never going to fire up a terminal. They're never going to understand what Docker is. They're never going to care what it is, containers, yada, yada, yada. It has to be drop dead simple. So we're trying to also facilitate that. So, all right, so now over here, you can choose the pipeline, and it gives you a quick little picture of what it's going to try and do, right? So in this particular case, here's a COVIDNet pipeline. Here's a COVIDNet application, right? And this is a neural network that wants to consume JPEGs. But our original image isn't a JPEG, right? Oh, well, no worries. We have another node above this that converts our medical image to JPEG, feeds it into the neural network. The neural network does its compute, creates a JSON file, and the JSON file is consumed by another plugin, which makes a nice PDF report. This is the kind of thing that doctors love, right? The point here is every single one of these circles you see is a completely self-contained container. And the Chris platform strings them together and executes and manages their compute. So I'm going to say, amazing, this is what I want to do. Hit next, create the feed, and now it's kind of trying to do its thing. So let me go over here. Again, I'm not going to explain too much here. This is more of a kind of developer or I'm going to say, more hardcore researcher view. For a doctor, we would have to have a much simpler UI, and we kind of do have this in some aspects with a COVIDnet UI, which I'm not sure I'll have time to touch upon right now. But all right, in the interest of speed, I'm not going to wait for this to compute because it's actually doing it all on its own. It's going through right now. And I'm going to go back to this one where I had run it just before the hackathon. Now, again, I'm simulating me being somewhere in South Africa on a little laptop, whatever, yada, yada, yada. And let's say I was so excited when the Brazilian team told me about this compute. I tried to run it on my patient, but boom, it failed, right? For whatever reason. Maybe it wanted a GPU, and maybe I don't have a GPU, or it needed more memory than what I had. There could be any number of reasons, right? So now I would almost be stuck. However, this is now the next part of the story, right? What we're trying to do is create this kind of collaboration between all of these instances. So instead of now being stuck over here, I could reach back out to the Brazilian team and say, you know what, I tried your amazing compute. It just didn't work on my topology. And they say, you know what, no worries. We're all one big happy family here. We're going to give you a authenticated one-time token, and you can tell your Chris to tell our Chris to run the analysis for you, because we've already set everything up, right? It's kind of like the opposite of this. I'm going to date myself here, but in the 80s, I'm a huge Star Trek fan. There was Star Trek II, The Wrath of Khan, and in this like pivotal scene, the Enterprise is squaring up against the Reliant, and the Enterprise tells the Reliant to lower its shield so it can escape, right? And that was like an amazing scene. Unlike that, because this is all good, our Chris is telling the Brazilian Chris, can you do this for us, right? So we're going to simulate that as well. So over here, I have a collaboration panel, and I'm going to click on my partner. And inside here, I'm actually now, this is a little bit of a manual thing. This is not supposed to be seen, right? But it should all be behind the scenes. But I'm going to imagine what you're seeing over here right now is actually my Chris speaking to another Chris that we have. And this is the Chris we actually have installed at Boston Children's Hospital. So I'm just going to quickly key this up, and I'm going to close this, and imagine we've done this, right? So here is where I've run that analysis that didn't work on my machine out on the Chris instance of Boston Children's Hospital. And I've been able to share my data to that other instance. And here's the compute. It's all completed. It's all wonderful blue, which tells us everything went perfectly well. But we start off, now here I can show you, here was our original input data. Here was the conversion of that input data. You will notice that it started off as a DCM file. We don't have to worry about what that is. This next plugin converted that DCM into a PNG. The PNG fed into the neural network. The neural network crunched it away and spat out a JSON file of its prediction. And the final node over here, the final chain, took that JSON file and created, I'm going to say a horrible, but nonetheless, a horrible PDF. Where I, as a doctor out in wherever I was in South Africa, could look at this and say, you know what, this patient that I was unsure about, I've run this analysis, potentially almost in real time, and I have my prediction from this analysis, right? Now, of course, I'm not touching on a whole bunch of stuff. Do you trust the compute? Do you not? Has it been vetted? Let's just imagine that's all done, right? Now, I want to show you as well, I'm pretty much finished because this is the whole story, but I wanted to show you as well over here, these nodes, if I click on more details, they actually execute in completely different environments. This first node executed on the local machine in which Chris was running. The next node over here, the conversion to the imaging format actually executed on an environment called BU21-9. This is a Power 9 IBM PC that's deployed out on the Massachusetts Open Cloud, and it's being served by Red Hat OpenShift for Power 9. So me, sitting in rural South Africa, I had no clue that my compute is being consumed by OpenShift or being scheduled ultimately through OpenShift on a Power 9 machine. It just all happened in the woodwork for me. And similarly, this next node, which did the actual the neural network, also ran on that high-performance Power 9 machine. And the final node over here ran on another machine inside the Boston Children's network in this particular case. And I'm going to stop right there because I'm sure I've gone over 7 minutes. But that is kind of the story that we're trying to do over here. Oh, I will say, just to finish it all up, right? everything you've seen here is totally open source. There's no non-open source element in this entire workflow. And I kind of want to just stop and just draw attention to the fact that what have we done here? What have we kind of simulated in this kind of example? We've simulated how, through sharing on these tools and how this platform, which is Chris, can be leveraged and set up, someone anywhere in the world is able to execute compute where it makes most sense, right? I imagine if I was still in this person in South Africa, I don't have a Massachusetts Open Cloud login necessarily, or a login into the Brazilian team's backend compute. But they give me a temporary authentication so I can actually leverage their compute without having to wait 3 weeks for someone to approve it and worry about yada, yada, all sorts of red tape. It just happened like that. Now, the real world doesn't work quite like that. I totally know it. But I'm just saying we have the technology that now enables this kind of stuff to go on.